All right, we're going to simplify this by doing the distributive property. So we have to do 5 square roots of 10 times 3 square roots of 2 minus the 5 square roots of 10 times square root of 15. Now, by the way, order of operations says to simplify inside the parentheses first, but since square root of 2 and square root of 15 aren't the same square root, I can't subtract those two. Okay, so that's why my next step is to do multiplication, which is the distributive property in this case. Okay, so now we're going to multiply each of these. So I have 5 times 3, that's 15. Now, you can just multiply 10 times 2 under the square root, or you can write it as in factored form, 5 times 2 times 2. I'm just going to write square root of 20 because it's a small enough number. And then over here, I just have a 5 on the outside, and I have 10 times 15, which is 150. You could leave it like that, but this one is a little bit bigger number, so I'm going to write it in factored form. Because 5 is a factor of both 10 and 15. So I'm going to write this as 2 times 5 times 3. Then it's sort of easy to see what the perfect square under that square root is. Now, for square root of 20, the perfect square is 4. You could have at this step written 4 times 5, right? Done the 10 times 2 in your head and then just written 4 times 5 instead of 20. But over here, let's see. Let's go ahead and just take the 5 out at this step so we know we'll be done with this part of the problem. So 5 times 5 is 25, and what's inside is 2 times 3. But over here I need to take a 2 out. So that's 15 times 2. 30 square roots of 5 minus 25 square roots of 6. Of course, there's still going to be unlike terms. If they were unlike, terms inside the square root before you did the distributive property, you're not going to all of a sudden have the same square roots after doing the distributive property. You'll still have just these two terms. And that's one way to do that problem.